So today's GFG problem is about um, ZigZag traversal, right? So first you have to basically um, print 1, then 3, 2, then 4, 5, 6, 7, and then 15, 14, 13, 12, so on. So, okay. So, to see, you can do a normal BFS traversal and then, you can alternate the those traversals, but uh, one more method is that I'm going to tell you over here is maybe you can let's assume that you have printed till over here. Okay, so you have printed 1, 3, 2, and 4, 5, 6, 7. Okay, and now you have to print the elements, other elements. So currently you are at 7. Okay, currently you are at 7. Now, what is the next output that you are expecting? It is supposed to be like, 15, 14, and so on, so right? 15, 14, 13, 12, and so on. So what you could do is, um, you know, you can take it into a stack. Okay. So maybe you can just print your right hand side first. So that will be 15 and then the left hand side. Okay. But after this, you do not have the access to 6 again. Okay. So you do not have the access to 6. So you cannot print 13 and then 12. Okay. So before you print these 15 and 14, when you are at 7, you should be having somehow these elements stored somewhere, right? Like 8 to 9, which is stored somewhere. So let's go back a little. So let's say when you are printing 4, 5, 6, 7, at 4, what you do is, you just print 4. That is fine. But what you do is keep the track of 8 and 9 somewhere. Okay, so what I mean is, so you're going from right to left. So in the next iteration, this 8 is supposed to be the last element, right? So do you remember, like, what is this data structure? So the data structure is stack basically. So here you will just put 8 and 9 over here, okay, in the stack. Then you would have 5 in the queue. So what you can do is, you can just take that 5 and put its left element and then the right element, okay, in the stack. Similarly, you can take, then you will be having 6 in the queue, 12 and then 13. Correct. Let's just take this over here. Okay. So now you will be having 12 and 13, and then you will be at 7. You can just push your 14 and 15. Okay. So at this point, see, your queue will be empty because you will not be having any kind of elements over here. Okay. So in the next iteration, what you could actually do is your queue is empty. Now check whether your stack is empty or not. Okay. So your stack is not empty. So what you can do is now you can empty all of these elements into the queue. Okay. So but in this manner. Okay. So that will be 15, 14, 13, 12, 11, 11, 10, 9, 8. Correct? So now you can just take out from the queue and then go forward. Okay, so the output will be 15, 14, 13, 12, 11, 10, so on so over here. Okay, so this is for this particular direction. Okay, let's say that you are at 3, let's say. Okay, so you are printing 3, but in the next line of statements, you want 7 to be printed last. Okay, so once say these two elements are in the queue. Now, in the next line of statements, you want 7 to be at the last, right? Right, 7, 6, 5, and 4, right? So this will already be there in your queue. 3 and 2 will already be there in your queue. Okay, so the next line of statements, as I said, is 7 you want it to be the last, and 6 and then 4 and then 5. Sorry, 5 and then 4. So in this case, you should put your right element first. Okay, so 7 is the first that I will add to stack, then I will add 6. Then 3 is out of the queue, then comes 2. Then on 2, we will again put the right element first. Yeah, right element first and then the left element. Correct? And then 2 will also be out of queue, and this is the stack that you will have. Again, similar thing, we will put it in the queue, that is 4, 5, 6, 7, and then we will follow the same pattern. Okay, so here, if you can see, the direction is from left, sorry, right to left. So when the direction is from right to left, maybe we can call it as direction is equal to 0. That actually means right to left. And in that, we will push the right first and then the left. Okay, we will push the right child first and then the left child in the stack. Okay, but in this direction, if you see, what we did was we pushed the 8 first and then the 9, right? So after this, after this traversal, we can just make a direction is equal to 1 and we can have so direction is equal to 1 means we have the direction from left to right, and in that we will push left child first and then the right child. Okay, so this is the whole idea of how we can have a traversal in a zigzag way. I will just show you the code. So here, if you see, what I have done is I have initially taken a direction. So yeah, I have taken a stack, which I just showed you. I have a queue and an answer uh, to keep all the elements. Okay, so in answer, whenever you will pop out any element from the queue, we will just put it into the answer. So initial direction is 0, and in the stack, I will have the root element first. Okay, that is the one I have pushed into the stack. Now, while stack is not empty, so as I said, you will take out all the elements from the stack and then put it into the queue, right? So this is what these three lines does. It will take all the elements which are there in the stack and then it will push it into the queue. So right now there is only one over here. Now the direction is 0, remember. Now we will take out all the elements from the queue and then push it into the answer. So right now we only have answer is equal to 1. Okay. So the first element we have printed. So after that we will check what is the direction. Okay. So the direction is 0. So what I will do is I will push the left element into the stack and then the right element into the stack, right? So we will push 3 first and then 2 first, okay, into the stack, and then we will change the directions. Okay. After this, again, we will check if our stack is empty or not. So no, it is not empty. It is 3 and 2. So we will first print, so like we will first put these 3 and 2 into the queue over here again. Then what we will do is we will take out the elements like 3. We took out 3 and we have uh, took it into the answer. After that we check the direction. Now the direction is 1. Okay, now the direction is 1. So I will push 7 first into the stack and then 6 into the stack, right? After that I will take 2 from the queue and then push 5 into the stack and 4 into the stack. Okay, so right now in my answer I have 1, 3 and 2. Okay. After that, in my stack, I have 4, 5, 6, 7. Remember, first I took 3, so I had 7, like 6 and 7. Like this is at the top of the stack, 6 is at the top of the stack, and then I took 2, so 4 is at the top of the stack, and then 5. So again, I will take all the elements from the stack and push it into the queue. So that will be 4, 5, 6, 7. Okay, I will take it and then I will just pop it out. So my answer will be 1, 3, 2, 4, 5, 6, 7. Again, the direction will be reversed and the story will continue. Okay, so that's the basic code. If you see, I'm just going to compile it. So submitting it. Yeah, so it has got submitted. So yeah, that's the logic behind this code.